Trig at the corners. What do I mean by the corners? They're not really corners, but if you think about it, an angle where the terminal side lies on the initial side is 0 degrees, right? An angle where the terminal side goes straight up and the initial side is, of course, the x-axis has got to be 90 degrees, right? A straight angle. So initial side looks like that. Terminal side looks like that. Has to be 180, right? Okay. If the terminal side goes down, straight down, got to be 270. Just add another 90 degrees because this quadrant, this third quadrant has angle 90 degrees, right? So just add another 90 degrees to 180, you get to 270. Add 90 more degrees and you're at 360. So this is also 360 when you go all the way around, right? Okay, so that's what I mean by the corners. 0, 90, 180, and 270. What are these values? Okay, let me fill in this chart and then I'll give you an idea of at least where some of these come from, okay? So the sine of 0 degrees. The sine of 0 degrees is actually 0. Okay? The sine of 90 degrees turns out to be 1. The sine of 180, 0. The sine of 270 is -1. The cosine of 0 turns out to be 1. I'll show you why that has to be true in just a minute. Where the cosine of 90 is 0, cosine 180 is -1, cosine of 270 is 0. Now, if you know these first two columns, how can you get tangent? Now I think I gave this to you last time. The tangent of theta turns out is sine theta over cosine theta, right? This is it's called an identity. It's identically true for all values of theta on which tangent's defined. And it's useful to know because it can help you remember some of these trig functions of special angles. So what's the tangent of 0 have to be? Just create the ratio. What's the sine of 0? The sine of 0 is 0. What's the cosine of 0? What's 0 divided by 1? No, 0 divided by 1. Okay, 0 divided by any constant k is okay. It's okay to do that division, and it's equal to 0. 0 divided by some constant, oh, sorry, I already did that. N, some constant divided by 0 is undefined, and it's not okay. No, right? NO. This is undefined. I know it's lame, but it's a way to remember it. Okay? So 0 divided by 1, that's okay. That's 0. Okay, now let's take the tangent of 90 degrees. In that case, you get the sine over cosine 1. The sine of 90 is 1. The cosine 0. Is that okay to divide by 0 there? So we say this is, it doesn't really make sense to say equals undefined, but we say it's undefined. Looks like a 0 with a slash through it. That means undefined. What about the tangent of 180 degrees? Sine over cosine in that case is what? 0 over -1? That's 0. So in other words, the tangent of 180 is 0. It's okay to take 0 and divide by -1, right? And then the tangent of 270, is that going to be okay? No, that would be -1 over 0, not okay, undefined. Okay? This chart is another one of those that you need to memorize. Now, where do some of these values come from? Let's do, this one's always weird looking, the fact that the cosine of 0 degrees is actually 1. So let's verify that one just by drawing a picture. And it's easy enough to draw this picture. Let's, we don't have to draw it in standard position, but I'm going to anyway because it helps with the others. So let's draw an angle that's not 0 but close to 0. Relatively close. That's not actually all that close, but so let's say this is theta. And let's drop a perpendicular. And let's call the adjacent side x and the hypotenuse r. Then what is the cosine of theta equal to? X over r. Right? Everybody agrees with that, right? But what happens in this picture when you bring this angle closer to 0? What is r actually going to approach? Or what is x actually going to approach? That would be a better way to say it. So let me see if I can draw another picture so you can see this, where the angle is closer to 0. So let's say we have this angle here. A little bit closer anyway. And let's say this is our triangle here. And then draw another angle. Let's cut that one in half. Like that. Do you see that this hypotenuse, this, I guess, pink or purple hypotenuse, or rather, maybe it'd be easier to think of in terms of x. So do you see then that when you compare the terminal side in green to the terminal side in purple, the terminal side in purple is closer to having length x, isn't it? Yeah, and in fact, when this angle in here goes to 0, x and r are the same. That's the argument. When theta equals 0, x and r, all right, let me just say x equals r. X equals r. But doesn't that make the cosine of theta x over x or r over r, which is 1? And in particular, theta is 0 in this case. So you could arrive at this chart then by making those kinds of arguments.